And hello everyone, Dwayne here. Welcome back to the Radical of Math. Today, let's do some math, but we're going to do some hardcore math. No soft mamby-pamby math, no. We're going to do some straight ahead math. And your problem's a very simple one. Find the derivative, which is represented as y prime, of this function. X squared plus 1 quantity times 3x minus 7 quantity raised to the 8th, all divided by x squared plus 5x minus 4 quantity cubed. Now, I'm going to tell you right now, you're going to need all 5 of these things. Chain rule, product rule, power rule, quotient rule, and definitely patience and care. This is a natural problem that I looked at when I was revising recently and went, that's a good problem. Because if you can do this problem, you are going to be able to say, I can do at least 1/3 of Calculus 1. And so we're going to solve this like we were an undergrad. So I'm going to give you a moment to write that down, and then I'm going to show you how I would approach this problem. So as I get ready, I want to say thank you for the great support on the first ASMR video. We have a second one that is being processed right now. So that will be a part 1 of 2 parts. So I just want to say thank you in advance for the support you've been giving the channel. Also, we are testing some new chalk today. This is a very cheap chalk. Normally the white chalk you see on the channel is Hagoromo chalk. But I've been very pleasantly surprised by this very discount chalk. So, let's recap some rules. So, power rule is the derivative of x to the n is this. And then product so the product of f and g is f g prime plus f prime g. Sometimes you'll see it written this way, which I think is a little bit more neat. So you need those first 2 things. So on your paper, you should write that down because you're going to need it. Now, quotient is very challenging. So instead, we're going to do chain. And just remember, chain is that. dy dx equals dy over du times du over dx. And basically the concept of chain rule is starting on the outside and work your way in. And now, as promised, quotient. Quotient is not fun. So, start from the bottom and work up. That's quotient. So denominator squared on the bottom, and then on the top, you just have to remember the order. G f prime minus G prime f. So we've counted the 4 things that we're going to need to solve this problem. And so now what we're going to do is we're going to do some intermediate work. Because we know we've got to use quotient rule. to do this. So let's go ahead and do some of our intermediate derivatives. Okay, so those are our intermediate derivatives. So the derivative of x squared plus 1 is 2x. The derivative of 3x minus 7 quantity to the eighth, got to have chain rule here. So power rule plus the inner, or correction, times the inner function. And we'll combine when we get to the point. And then on the denominator, power rule again plus chain rule on the inside. So we now know what is required. So let's get started. So some of you are going, well, why aren't you combining this to make it a 6th power? The reason is I'm looking for simplifications. So I'm going to keep it this way just to where I don't lose track. And so at the top, and now we need the product rule of this. So we're going to leave that right there, minus, and then we're going to need the derivative of this. Well, we've already done it. So all I did is this whole thing I'm treating as a function. I have my g prime, which is this bit right here. So the other thing we got to do is the product rule. So we've already done some of the math already. There we go. So this is a monstrosity, but now you see why I kind of left things. That way we can factor and do stuff. So from left to right, G, which is this right here, product rule. So I'm treating this whole thing as a composite function. I'm going to call it H. This is H. And this is product rule here. So we've done the steps already. So this whole thing is a summation minus G prime, which is this bit here. So I went ahead and distributed the 3 to these two terms. That. Now, astute people are going to go, oh, I can start simplifying some things. Yes, you can. So let's deal with the first thing. So the first thing is these are going to go away. Boom. So let's just go ahead. So these two go away. So I've just rewritten it. And then over here, we're going to have So what we've done is we've taken 2 of these out and we're leaving it as that. So now we need to continue simplification. So we can take this out and put it on the outside. We can also take 7 of these out from both. So let's go ahead and do that. And now what do we have left? Well, the second one is pretty straightforward. We're going to have 1 of the 3x minus 7 left. But it's the left side we got to be very, very careful of. So let's go ahead and let's deal with the right side first. And then we're going to have 1 of those. There we go. So this, all we've done is pulled out common factor from both. Now we're going to deal with this bad boy right here. So I have 7 of these that's out. So what I have left and you'll notice I can take out another x squared plus 1, so that's coming. And all that's over 1 because we've taken cubed out. Now, on second thought, I can't take this out because this doesn't have a like term. There's nothing for me to multiply. So, now what I'm looking at is I can't take this out because I don't have 1 here. And so now we're kind of at the point where we can now simplify. Notice patience and care. So, let's see, 45, 42 is 3. Okay, so I'm just simplifying. Matter of fact, I'm going to go ahead and do that here. 30. Now, I could distribute this over here to where you have everything in common denominator, but I'm not. I'm just going to simply say we're good. This bottom value right here is your derivative. So the derivative of this is that. Yeah, that's a biggie. But if you were able to do this, give yourself congratulations. This is a very, very challenging problem. Make sure you like, follow, subscribe, and look forward to the next one with you. Take care of yourself. Take care of one another. God bless.